because they're often seen as first steps in speciation. Okay, so the Notodamus viridescens life cycle is really complicated, and this is an oversimplification and not often how it's portrayed, where you have eggs go to aquatic larvae develop, metamorphose into terrestrial S, and then they become semi-aquatic adults. However, this is what their life cycle can look like potentially with all these different phenotypes post-larval stage. So you can still have metamorphosis to terrestrial Fs. However, there's another juvenile stage, which are aquatic juveniles. So the juveniles can either be terrestrial or aquatic. However, the juvenile stages can be skipped altogether, so they can metamorphose directly into semi-aquatic adults. So you have three forms of metamorphosis, but that's not all. These individuals can also go through a form of paedomorphosis, which is the retention of juvenile characteristics into adulthood. So they can become aquatic neotines or aquatic branchiates. The difference between these is somewhat small. It deals with the degree of metamorphosis that they go through. Newts are almost all aquatic branchiates. But I threw in aquatic neotines here because there have been a few recorded instances of neotines. And most other paedomorphic salamanders are actually neotines, so newts are a little bit different in that they're aquatic branchiates, which means they go through a little bit more metamorphosis than neotines. So each of these stages can then eventually develop into adults. These four on the bottom here are ones that will typically be elicited when there are good aquatic conditions. And as you can see, the semi-aquatic adults are sexually mature, as are the paedomorphs. So these three will be breeding immediately in the next breeding season. So they should have higher lifetime reproductive success compared to terrestrial S, which take up to 8 years to reach sexual maturity. And the aquatic juveniles are like miniature adults, so they will also reach sexual maturity by the time the next breeding season rolls around, which could be 3 to 4 months. So determining phenotype is going to be very important for these individuals because it can have big impacts on your lifetime reproductive success. So I was interested in what types of cues elicit these different phenotypes. And there was a study done in 1987 by Reed Harris where he looked at density effects and how that could influence the different phenotypes. And he did a mesocosm study with Notodamus viridescens dorsalis, which is the broken striped newt. And he just simply manipulated 2 levels of density, low density, high density. And he took these individuals from hatching to changing phenotypes, so either metamorphosis or paedomorphosis. And at low density, he got mostly aquatic forms. So most individuals became paedomorphs or adults. And at high densities, most individuals, due to crowding effects, metamorphosed and became Fs to escape that poor quality habitat. So high density seems to be a cue of poor quality habitat. However, when you're manipulating density, all these other variables become confounded. Importantly, food becomes confounded, so the amount of food per capita in high density environments is going to be different compared to low density environments. And also the amount of space each individual is going to be able to have, the frequency of aggression between individuals is going to scale with density, and the concentration of chemical cues will also be scaling with density. So by what mechanism is density dependence actually operating? So there has been some evidence that density directly affects amphibian development, and it does that unrelated to food. Richter et al. Did a study where he actually controlled the per capita food rate intakes on Rana spinocephala and found that it increased development rates. So I did a study at the Tyson Research Center, which is just outside St. Louis, and I was trying to tease apart some of these factors and what is actually the mechanism going on in this density-dependent system. And I used Notodamus viridescens louisianensis, which is the central newt, and I set up 14 breeding mesocosms with male and females. These are 1,200-liter cattle tanks, so these newts are obviously not to scale. And these individuals just laid eggs individually in the aquatic vegetation. They wrapped their eggs in the vegetation. I had to pick through levels. And this is how I get my 2x2 factorial design, constituting 4 different treatments. And I would like to point out that